The importance of electrical safety for plumbers is paramount. Plumbers encounter various electrical hazards in their daily work. Understanding and adhering to legal and regulatory requirements for electrical safety is crucial. Basic electrical theory involves understanding voltage, which is the electrical potential difference or pressure that drives the flow of electrical charge. Current is the rate of flow of electrical charge, measured in amps. Resistance is the opposition to the flow of electrical current, measured in ohms. Electrical circuits and components form the pathways for electrical current. Types of electrical systems include alternating current, known as AC, and direct current, known as DC. Electrical wiring methods dictate how electrical conductors are installed and protected. Safe work practices are essential, including lockout-tagout procedures which ensure that electrical equipment is de-energized before work begins. Personal protective equipment, known as PPE, such as insulated gloves and eye protection, must be used. Hazard identification and risk assessment are key to preventing electrical accidents. Grounding and bonding provide a low-impedance path for fault current, minimizing the risk of electrical shock. Wiring inspection and testing verify the integrity of electrical installations. Emergency procedures must be in place to respond to electrical incidents. Understanding electrical service panels is essential for plumbers who may need to disconnect power. Disconnecting electrical power to appliances such as water heaters and garbage disposals requires specific procedures. Troubleshooting basic electrical problems can help plumbers identify and resolve issues safely. Installing ground fault circuit interrupters, known as GFCIs, provides additional protection against electrical shock. Requirements for electrical permits in Washington state ensure that electrical work is performed safely and complies with regulations. The process for obtaining permits and inspections involves submitting plans and documentation to the appropriate authorities. Inspection procedures and documentation verify that electrical work meets safety standards. Hands-on activities, such as safely disconnecting electrical power to a water heater, provide practical experience. Installation of a GFCI outlet demonstrates proper wiring techniques. Troubleshooting a basic electrical circuit reinforces understanding of electrical concepts. Assessment through a written or oral exam evaluates understanding of electrical safety concepts. A practical demonstration assesses hands-on skills. Firstly, it's important to understand the basics of voltage. Voltage is the electrical potential difference between 2 points in a circuit. It is the driving force that pushes electrons through the circuit. It is measured in volts. Secondly, you need to grasp the concept of current. Current is the flow of electrical charge through a circuit. It is the number of electrons passing a given point in a circuit per unit of time. It is measured in amps. Thirdly, it is essential to know about resistance. Resistance is the opposition to the flow of electrical current in a circuit. It is measured in ohms. A higher resistance means that it is more difficult for current to flow. Ohm's law describes the relationship between voltage, current, and resistance, where voltage equals current times resistance, or volts equals amps times ohms. Electrical circuits are complete paths through which electrical current can flow. They typically include a voltage source, conductors, and a load. There are two main types of circuits, series and parallel. In a series circuit, the current flows through each component in sequence. The total resistance is the sum of the individual resistances. In a parallel circuit, the current has multiple paths to flow through. The voltage is the same across each component, and the total current is the sum of the individual currents. Electrical components are devices that perform specific functions in a circuit. Resistors limit the flow of current. Capacitors store electrical energy. Inductors store energy in the magnetic field. Diodes allow current to flow in only one direction. Transistors are used for switching and amplification. Alternating current, known as AC, is the type of electrical current used in most homes and businesses. The current periodically reverses direction. Direct current, known as DC, flows in only one direction. Batteries and electronic devices often use DC power. Electrical wiring methods specify how electrical conductors are installed and protected. Common wiring methods include conduit, cable, and surface raceway. Conduit provides a rigid protective enclosure for conductors. Cable consists of multiple conductors bundled together within a protective jacket. Surface raceway provides a channel for conductors to be run along a surface. Safe work practices are essential for preventing electrical accidents. Lockout-tagout procedures ensure that electrical equipment is de-energized before work begins. This involves disconnecting the power source, applying a lock to the disconnect, and tagging it to indicate that it should not be re-energized. Personal protective equipment, known as PPE, must be used when working with electricity. Insulated gloves protect against electrical shock. Eye protection prevents debris from entering the eyes. Flame-resistant clothing protects against burns. Hazard identification and risk assessment are crucial for preventing electrical accidents. Identify potential electrical hazards such as exposed wires, damaged equipment, and wet environments. Assess the risk associated with each hazard, considering the likelihood of occurrence and the severity of potential injury. Grounding and bonding provide a low impedance path for fault current to return to the source. This helps to prevent electrical shock and equipment damage. Grounding connects electrical equipment to the earth. Bonding connects non-current carrying metal parts together. Wiring inspection and testing verify the integrity of electrical installations. Visual inspections can identify damaged or improperly installed components. Continuity testing verifies that circuits are complete and there are no open circuits. Insulation resistance testing measures the resistance of the insulation surrounding conductors. Emergency procedures must be in place to respond to electrical incidents. Know the location of emergency shutoffs and how to use them. Be familiar with CPR and first aid procedures. Report all electrical incidents to the appropriate authorities. Understanding electrical service panels is essential for plumbers. The service panel is the main distribution point for electricity in a building. It contains circuit breakers or fuses that protect individual circuits. Identify the main breaker and how to shut off power to the entire building. Disconnecting electrical power to appliances such as water heaters and garbage disposals requires specific procedures. Locate the circuit breaker or fuse that supplies power to the appliance. Turn off the breaker or remove the fuse. Verify that the power is off using a voltage tester. Troubleshooting basic electrical problems can help plumbers identify and resolve issues safely. Check for tripped circuit breakers or blown fuses. Look for loose connections or damaged wiring. Use a multimeter to test for voltage and continuity. Installing ground fault circuit interrupters, known as GFCIs, provides additional protection against electrical shock. GFCIs detect ground faults and quickly interrupt the circuit. Install GFCIs in areas where there is a risk of water exposure, such as bathrooms and kitchens. Requirements for electrical permits in Washington state ensure that electrical work is performed safely and complies with regulations. Permits are required for most electrical work, including new installations, alterations, and repairs. Contact the local electrical inspection authority to determine permit requirements. The process for obtaining permits and inspections involves submitting plans and documentation to the appropriate authorities. Complete the permit application form. Submit plans showing the proposed electrical work. Pay the required permit fees. Inspection procedures and documentation verify that electrical work meets safety standards. Schedule an inspection with the local electrical inspection authority. Be prepared to show the inspector the completed electrical work. Provide documentation such as wiring diagrams and equipment specifications. Hands-on activities, such as safely disconnecting electrical power to a water heater, provide practical experience. Locate the circuit breaker that supplies power to the water heater. Turn off the breaker and verify that the power is off using a voltage tester. Disconnect the wiring to the water heater. Installation of a GFCI outlet demonstrates proper wiring techniques. Remove the existing outlet. Connect the wires to the new GFCI outlet following the manufacturer's instructions. Test the GFCI outlet to ensure that it is working properly. Troubleshooting a basic electrical circuit reinforces understanding of electrical concepts. Use a multimeter to test for voltage and continuity. Check for loose connections and damaged wiring. Identify the cause of the problem and make the necessary repairs. Assessment through a written or oral exam evaluates understanding of electrical safety concepts. The exam may cover topics such as electrical theory, safety practices, and wiring methods. A practical demonstration assesses hands-on skills. The demonstration may involve tasks such as disconnecting power to an appliance, installing a GFCI outlet, or troubleshooting a basic electrical circuit. It is crucial to always prioritize safety when working with electricity. Always de-energize circuits before working on them. Use appropriate personal protective equipment. Follow safe work practices. Be aware of potential hazards and take steps to mitigate them. By following these guidelines, plumbers can protect themselves and others from electrical hazards. Understanding grounding and bonding systems is a key aspect of electrical safety. Grounding ensures that non-current carrying metal parts of an electrical system are connected to the earth, providing a path for fault current to flow back to the source. This helps to prevent electrical shock in the event of a fault. Bonding connects all metal parts of an electrical system together, creating a low impedance path for fault current. This helps to equalize the voltage between different metal parts, reducing the risk of electrical shock. There are several types of grounding and bonding systems. The grounded system has one conductor of the electrical supply connected to ground. This is the most common type of system used in residential and commercial buildings. The ungrounded system does not have any conductor connected to ground. This type of system is typically used in industrial applications where there is a high risk of electrical shock. Equipment grounding conductors, IGs, are used to connect non-current carrying metal parts of electrical equipment to the grounding system. These conductors provide a low impedance path for fault current to flow back to the source. Bonding jumpers are used to connect different metal parts of an electrical system together. These jumpers ensure that all metal parts are at the same voltage potential, reducing the risk of electrical shock. Ground fault circuit interrupters, or GFCIs, are devices that detect ground faults and quickly interrupt the circuit. These devices are required in areas where there is a high risk of water exposure, such as bathrooms, kitchens, and outdoor areas. GFCIs work by monitoring the current flowing through the hot and neutral conductors. If there is a difference in current, it indicates that some of the current is leaking to ground. The GFCI will then trip, interrupting the circuit and preventing electrical shock. Arc fault circuit interrupters, or FSIs, are devices that detect arc faults and quickly interrupt the circuit. Arc faults are dangerous electrical conditions that can cause fires. FSIs work by monitoring the current waveform. If there is an abnormal current waveform, it indicates that there is an arc fault. The FSI will then trip, interrupting the circuit and preventing a fire. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Circuit breakers are reusable devices that trip when the current exceeds a certain level. Fuses are one-time use devices that melt and break the circuit when the current exceeds a certain level. It is important to select the correct size overcurrent protection device for each circuit. The size of the overcurrent protection device should be based on the ampacity of the conductors in the circuit. The ampacity is the maximum current that a conductor can carry without overheating. National Electrical Code, also known as NEC Table 310.15, details ampacities of insulated conductors. Working with electricity can be dangerous, so it is important to follow safe work practices at all times. Always de-energize circuits before working on them. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Follow lockout-tagout procedures to ensure that circuits are not accidentally re-energized. Be aware of potential hazards and take steps to mitigate them. If you are not qualified to work on electrical equipment, hire a licensed electrician. Always follow the National Electrical Code, also known as NEC, when installing or repairing electrical equipment. The NEC is a set of standards that provides guidance on how to install and maintain electrical systems safely. The NEC is updated every 3 years, so it is important to stay up to date on the latest requirements. Electrical safety is everyone's responsibility. By following safe work practices and being aware of potential hazards, you can help to prevent electrical accidents. Always call a licensed electrician for any electrical work that you are not qualified to do. Remember to always respect electricity and treat it with caution. Always assume that a circuit is energized until you have verified that it is de-energized with a voltage tester. Never work on electrical equipment in wet conditions. Never overload electrical circuits. Never use damaged electrical equipment. If you have any questions about electrical safety, consult a qualified electrician or electrical inspector. Staying informed and adhering to safety protocols are paramount in preventing electrical hazards and ensuring a safe working environment. Continual education and training are critical for staying abreast of the latest safety standards and best practices in the electrical field.